welcome to day 21 of our 30-day coding challenge from CS and Math. A question that we get a lot is just like, how do we get our feet wet? Like, how do we get started? And so I thought I would give something basic. A question that teachers are always asking is, how do we just code basic formulas? We spend so much time on hand computation. How can, once they have the generalization down, how do we capture it? So that's what I was going to cover today. This is actually a lesson from our website. In our website, we do this in Scratch. So again, if you searched programming, you'd probably have to search CS and Math or company and then programming any formula, and you'd get this lesson in Scratch. So we're just doing this challenge in Python, and we're going to break it down to these 3 steps. So I'm going to let you get set up, delete out this starting piece, and we'll get started. Okay, so a basic formula that's used frequently is converting from Celsius to Fahrenheit. We like it just because it has a fraction in there and includes decimals and some other things. But really this will work for any formula, the basic structure we're about to talk about. So this one, again, is a good starter one because we just have a single input and a single output, right? You'll typically just have a single output, but sometimes you have multiple inputs. So let's say we have a bunch of temperatures in Celsius and we want to convert them to Fahrenheit. How could we program this formula? And so you have to ask yourself, what would you take an input? In this case, we would prompt for the input of Celsius. Now we spell that wrong for some reason. And Celsius equals, we can put anything now for, let's just put 10 there as a placeholder. Now I chose 10 because if you look at the formula, I realized that the denominator here is 5. Like, if I took 10 and input it here, 10 divided by 5 is 2. 2 times 9 is 18, and then 18 plus 32 gives a clean answer like 50, and I know that, and I can see that. Now again, we're not saying to just skip that altogether. We want kids to be able to evaluate using fluency and their understanding of numbers, but once they've captured it, once we know they have it down, let's give them a new literacy by showing them how to program it as well. Then they've captured it for the long haul, and then they could do it for multiple programs down the road whenever they want to, whenever they're doing applications out there. So what are we going to do with that? Well, to convert it to Fahrenheit, we need to create that variable. So write down Fahrenheit. So Fahrenheit equals, and this is where we type in our formula. Now I like to put all my fractions in parentheses. That's just a habit that I like, and I recommend it for you too. So 9/5 times that Celsius. And you don't have to write Celsius out here. You can just put C and F, and that's fine too. But then we are going to take that and we're going to multiply that by the Celsius, and we are ultimately going to add 32. And again, we recommend starting with something easy, like an easy number like that, so we can see if that is working. And our third step, we said, was to display the output. We want to basically show Fahrenheit. So I would just click print. That's our display command in Python. We're going to print Fahrenheit. And if we run this, notice how I have an issue here. It's going to tell me what my issue is. So this is good and it's very common. So it says print Fahrenheit, missing parentheses in call print. Now that's interesting. I am in Python 3 here today, so maybe that has something to do with it. Typically we don't need these, but let's just put them in there. We've read this, we've thought through what it is, we know what the error is, and so now if we run it, we see that we do get 50. Again, sometimes you have to be very aware of the order of operations, and you want to test multiple values. So what's another easy value, let's say, that you could plug in here, or students could plug in here? And you might have different things. Let's say we just say 20, 20 degrees Celsius, and just double this. So we'd say, okay, if I plugged a 20 in there, excuse me, 20 divided by 5 is 4, 9 times 4 is 36, and those add up to 68, just so I have an idea of what to expect, right? And this is part of just verifying that your code is executing correctly. Another idea is, okay, well, we're only plugging in whole numbers here. What if we wanted to do something that was decimal based? And again, you can pick something simple like, let's say it was maybe 0.5 is easy. 0.5 divided by 5 is 0.1. 0.1 times 9. And these are just really good habits for kids, and they're testing and verifying that their programs work. And so we can see that that one works, as expected, right? So I did that a little slowly just to be sure that we had it. Now I'm gonna change this. So we've definitely got our structure here, but we never did prompts. And a lot of times when you're doing these programs, kids will want to actually not hard code it. They'll want their program to just execute depending on the platform. So like for example, if I prompted for input and I called that Celsius equals, and then I'll put a space. So I'll put maybe like that. If I run this, now notice how it says, what is the Celsius equal? And if I now put 10 in here, it's going to say, wait a minute, there's a problem. It says can't multiply sequence by non-intiv type float. So anytime we type this in, this is text. We've covered this already. Let's try to convert it to just a number like an integer. So it's having issues here in line 4, and they're trying to sub in this Celsius, right? So then I would run this, and I would type in 10, and it would work for 50. I'd run it again. I'd try the decimal 0.5, and I would run it. Oops. Hit enter. Notice it doesn't like that because we're typing in decimals. Decimals aren't integers, right? Those are called floats. So I think what's best for our program is probably a structure like this. So if I ran this and it says what's the Celsius, I would say 0.5, and now it's going to execute. So this is just, some structure type of things about knowing the programming language. This is just the way Python does it. Hopefully, though, you found value and found that helpful. And so to end with here today, maybe we'll ask a question and say, what is a formula that you see happen a lot that's a pain for kids, and they just want to be able to partner their knowledge with this computational skill set? So a lot of people would say we keep covering quadratic formula, and quadratic formula does have a place, even though a lot of people think it doesn't. It's just the nature which by we're using it. So let me just pull it up, and we are actually going to do this tomorrow in the challenge and try to look at it more from a big picture, holistic point of view, and how it could be really good just for kids' logical sequence. But if you were going to program this equation, what would you need? And if you go back here, hopefully you're saying for our prompt and input, we're not just going to be able to prompt for one thing, right? We can't just prompt for one input. Now we have 3 inputs, A, B, and C, right? And maybe you've tried to program this before. If you have, but never in Python, maybe you go ahead and just try to write your program now. In any case, we hope that you'll join us back tomorrow as we do walk through that. We'll show you how to use it to reverse factor and a few other things. So welcome you guys to that. I know this one was kind of more down to the basics, but hopefully it helped your understanding and filled in some gaps for me. As always, hit that like, hit that subscribe. Thank you guys for joining us, and we'll see you tomorrow. Thanks.